Hello everyone, this is Wafu TV. Here we demystify elementary mathematics and we equally support the education of the underprivileged learners in local communities. At Wafu TV, we do a lot as far as elementary mathematics is concerned. In our last lesson, we talked about the different relationships that exist between sets. So in today's lesson, we are going to talk about the different operations that we can do or carry out as far as sets are concerned. In the very first aspect of it, we are going to look at the intersection of sets. What is intersection of sets all about? Intersection of sets are elements that are common or present in two or more sets. So let's look at the elements that are common in A and in B. We have 5 here and there is 5 here. Then we have 7 and there is 7 here as well. For our intersection of this set A and B, we have 5 and 7. Let's quickly go to B, union of a set, and it is denoted by this sign. Union of a set simply means all the elements that are common to 2 or more sets. Now, what we can take note of as far as union of set is concerned is the fact that if these are numbers or letters, you arrange them, you rearrange them so that you start with the least and end with the most. Let's look at the example we have on the board. We have the set F and the set H. The set F union H will be all these elements put together. In these two sets, we have 8 here, which is the least element. The next is 9, 10. We have 11, 12, 13 here, 14, 15, 16, 17. We don't have 18, so take note, you don't include an element that is not present in any of the sets, but we have 19. So 19 here will be the last element. If this is understood, then let's proceed to the next aspect of operation. Complement of a set. Complement of a set are those elements that you find in the universal set, but you don't find them in a particular set. Let's look at this example together so that you can better understand. So we have the universal set here, and the elements in the universal set are numbers from 1 up to 10. Let's refresh our minds again on something here. 5, 6, 7, 8, and 9 are not in this set, but they are present in that set because this dotted line represents the numbers that are not shown there. And the set Y is 1, 3, 5, 7, and 9. Here they are asking us for the complement. This is the sign for complement. So Y complement are those elements that you can find in the universal set, but you cannot find in set Y. 1 is present here, 2 is not, 2 is one of them, 3 is here, 4 is not, so 4 is another, 5 is here, 6 is not, 7 is here, 8 is not, 9 is here, and 10 is not. These are the complements of set Y, which means if you take all these elements in Y complement and add to Y, it's going to make the universal set. It completes the universal set. Alright, let's go to the last aspect of our today's lesson, which is the associative property. The associative law says that no matter how you group the elements of the different sets, it gives you the same result. Let's do this practically for better understanding. Let's first of all solve what is in the parenthesis. That is A intersection B. A intersection B gives this 6, which is here and here, and we have 8, which is here and here. Then we have to look for the intersection of this and C. So what do we have in this set that we have in the set C? In this set we have 6, and in set C we have 6. We have 8 here, and if you look at the set C again, you have 8. Now let's look at if you group it the other way around. That is, we find B intersection C first. What do we find in B and in C? 6, we can find 6 here and 6 over there, and we can find 8 and 8. So we have 6 and 8. Let us look at what you can find in this set, B intersection C, and in A. 2, we don't find it here. 4, we don't find it here. 6 and 8, you can find it there. So 6 and 8 are in A and in B intersection C. That is to tell you that no matter how you group it, the result will remain the same. This is for intersection. Let's do it for union to see if it's going to give us the same result as well. First, we start with A union B. All the elements in A and in B, starting with the list. You have 2, 4, 5, you have 6, you have 7, 8, and that is it. Take note that even though 6 repeats in A and in B, you write it just once. Same with 8. Now let us unite this set A union B with the set C. So let's start with the list. 2, 4, 5, 6, 7, 8. Then in C we have 9 because 6 is here, 7 is here, 8 is here. So the only number we add now is 9. Take note of this. Let us solve the last one. We first of all do B union C. In B and in C, we have the list number there is 5, 6, 7, 8, and we have 9. Let us join set B union C with set A. Starting with the list, you have 2, which is in A. You have 4, 5, which is in this set, 6, 7, 8, and 9. If you compare set A union B union C and A union B union C, you will find that the answers are the same. So no matter how you group it, either this way or this way, the answer, your final result, will be the same. You have 2 here, 4, 5, 6, 7, 8, and 9. This is all we had for you today as far as set operations are concerned. In our next lesson, we are going to be looking at Venn diagrams. So see you in our next lesson, and please do not miss it. If you love the lesson, subscribe to our channel, click the notification bell so that each time we share a lesson, you'll be notified. Thank you for today. To get more information, you can contact the numbers on the screen, or you can visit our website